So when we run a chemical reaction, the reagent that runs out first is going to be called the limiting reactant, or, and this should actually be parentheses, a limiting reagent. Both terms are interchangeable. You'll usually hear me call it a reactant, but either one works, okay? The reason it is called a limiting reactant is because once it runs out, the reaction stops. So it is what limits the amount of product that can form, okay? So here we have a balanced chemical equation. We're told that methane, CH4, reacts with water to form 3 hydrogen and carbon monoxide, okay? So I need 1 methane molecule, here's my C, and 4 H's, for every 1 water molecule. H2O, sorry, 2 H's, 1 O, okay? So here I've got some pictures, and I'll try to keep this like this, okay? So for every one of these, I need 1 of these. Well, that's what the little circle is. H2O, methane. H2O, methane. H2O, methane. H2O, methane. Methane, H2O. Methane, H2O. Well, I've still got stuff left over, but everything that's left over are water molecules. I have no more methane for them to react with. So because methane ran out first, we call it the limiting reactant. Because there's extra water, we call that the excess reactant. Now in my container at the end, if I had had exactly the same amounts of this as this, I would just have hydrogen and carbon monoxide, but that's not going to be the case. I still have some of my extra water molecules left behind because they did not change. I'm out of methane, okay? So here's the way we actually perform our calculations to determine who the limiting reactant is. I've got my balanced chemical equation down here. I'm told that if I have 18.1 grams of NH3 and I'm reacting it with 90.4 grams of CuO, I want to find the limiting reactant. Well, because I have 2 different numbers, I need to do 2 different calculations. I want to find out how much stuff I can make. Now, I have options. I can either change it into nitrogen or copper or water. It doesn't really matter. I'm going to pick one. Because this talks about nitrogen being prepared, I'm going to pick nitrogen. Now, the reason I could have picked any of my products is because I just want to find out which one of these makes less of any of my products. You'll usually choose an easy one that'll make the math pretty simple, okay? So what I would do is I'm going to set up 2 different calculations. One for 18.1 grams of NH3, and a second for 90.4 grams of CuO. Okay? So I want to change them both into grams of nitrogen. Whichever one runs out first is my limiting. So I've got grams of NH3. I want to make that go away. Step 1, I'm going to change it to moles. Okay? These are stoichiometric calculations, the 3-step problems. I know that the number from the periodic table is equal to my grams. If I look at my periodic table, N equals 14, H equals 1, and I have 3 of them. So the whole thing weighs 17 grams, and the number from the periodic table is equal to 1 mole. Okay. Step 2, I now no longer want moles of NH3, so that goes on the bottom. Instead, I want N2. So remember, when I'm changing from moles of one element or compound to another, I look at the equation. I've got 2 NH3. I've got 1 N2. Okay. Last step, I want to change moles to grams. So I want moles to go away. Change it into grams. Now remember, anytime I want grams, I look at the periodic table. I said nitrogen weighed 14. There are 2 of them. So 28 grams of nitrogen is equal to 1 mole. If I plug this into my calculator, I get 14.905. I started with 3 significant figures, so I keep 1, 2, 3. So that becomes 14.9 grams of nitrogen. Okay? That doesn't tell me the limiting. I have to do the same thing for copper 2 oxide. Okay? So here, I need to get rid of grams of copper 2 oxide. I need to change that to moles. I know that 1 mole is always equal to the number from the periodic table. Copper is 63.5, so let's go ahead and make that 64. Oxygen is 16, so that's 60. So now I need to get rid of moles of copper 2 oxide. Instead of copper 2 oxide, I want nitrogen. Okay. I get my numbers from the equation. 1 mole of nitrogen for 3 moles of copper 2 oxide. Okay. And then I'm going to do the same thing in step 3. I get rid of my moles of N2, and I'm changing it to grams of N2. I know that grams is equal to the number from the periodic table. I already did this math. It's 28, and the number from the periodic table is equal to 1 mole. Okay? So now, when I plug this into my calculator, 90.4 divided by 60 divided by 3 times 28, I should get 10.5466. I started with 3 sig figs, so I only get to keep 3 sig figs. 1, 2, 3. So that rounds to 10.5 grams of nitrogen. Now they both had to be converted to the same product. And the reason they have to be the same product is I need to compare them to each other. In this case, because 10.5 is my smaller number, the reactant that gave me the 10.5, so the 90.4 grams, is my limiting reagent, or limiting reactant. Remember, same thing. It gives me the smaller amount of product, it runs out first, and so it limits the reaction. Okay? So when we talk about our reaction, our theoretical yield is what we should actually make. Okay? So it is going to be how much that we should make theoretically, if all of our limiting reactant is completely used up. Now this is if 100% of my reaction went to completion. So in this case, okay, my limiting reactant was CuO, copper 2 oxide. If 100 of it went to completion, 100%, all of it, I would make 10.5 grams of nitrogen. This is my theoretical yield. It's how much I absolutely should make, okay? So to calculate the percent yield, I would take my actual yield. This is what I really make in the lab. I divide that by what I should make based on calculations. And if I multiply that by 100, then I will get the percentage that I made. Now, obviously, I want 100% yield. For our purposes, anything about 80 is pretty good, okay? So they've got a little table. You can look that over if it's helpful. It just kind of sums up what we just did and talks about those steps. But here's what it would look like, okay? So take a second and solve example 16. It says that we're making methanol, CH3OH, okay? It says assume I've got 68.5 kilograms of carbon monoxide. I've got 8.60 kilograms of hydrogen, okay? What they want you to do is calculate the theoretical yield of methanol, okay? Once you calculate your theoretical yield of methanol, they tell you that you actually made 3.57 times 10 to the 4th. That's my actual yield, okay? So once I have my number, my theoretical yield is the small number I get from this, divided by my actual yield, or sorry, flip it. My actual yield divided by my theoretical yield, which is what I calculate here, the small number, times 100 will tell me my percent.